Hello, I'm Professor Rad, and today we're going to talk about the associative property. So, an operation has the associative property if you can alter the grouping of the numbers without changing the results of the operation. So, think about what the word associate means. Like if, you see a law firm and it's like such and so plus associates. Associates are people that you're kind of grouped with. So, they're people in your group. So the associative property says you can change the people or the numbers in the groups, and you won't change the outcome. So for example, if I look at this first instance here, I have 10 plus 2 plus 3, and the 3 and the 2 are grouped together. On the right, I have 10 plus 2 plus 3, and the 10 and the 2 are grouped together. So let's see if changing the grouping makes a difference for addition. I have to do the operation in the grouping symbol first. So 2 plus 3 is going to be 5. And then if I add 10, I end up with 15. On the right-hand side, the 10 and the 2 are grouped together. So let's do that first. 10 plus 2 is 12. And then I'm going to add the 3. 12 plus 3 is 15. So it looks like even though the grouping changed between these two expressions, the answer is going to be the same. So this is good evidence that addition likely has the associative property, that we can change our associates when we add. I wonder if that works with subtraction too. So here we have 10, 2, and 3, 10, 2, and 3, same situation, but we've changed the groups. On the left-hand side, the 2 and the 3 are being grouped, and on the right-hand side, the 10 minus 2. So let's follow our order of operations and see if we get something different. 2 minus 3 is a negative 1. I'll bring down my 10 minus. 10 minus negative 1, if I do my keep, change, becomes 10 plus a positive 1, which is 11. So 10 minus the quantity 2 minus 3 is going to give us 11. On the right-hand side, we've got to do 10 minus 2 first. So 10 minus 2 is 8. And 8 minus 3 is 5. And 5 is not 11. So it looks like subtraction does not have the associative property. So we can play around with this with other kinds of operations like multiplication, division, exponents, and oh golly, look at this one, radicals. We'll do that for now. So let's do the multiplication first. So I've got 2 times 3 in parentheses. That's going to give me 6. And if I do 10 times 6, that's going to get me 60. On the right, I've got to do 10 times 2 first, which is 20. And 20 times 3 is going to give me 60. So whether the 2 and the 3 were grouped or the 10 and the 2 were grouped, we got 60 either way. So it looks like multiplication likely has associativity as well. How about division? Ooh, I think I'm going to have to use a calculator for this one, because I don't think 3 goes into 2, so we're probably going to get some decimals. So if I do 2 divided by 3, yeah, I get this repeating decimal. So I'm going to get 10 divided by 0.6 repeating. So on this calculator, I could type in 10 divided by this answer without having to type in all those 6s. Here's how I do that on this particular calculator. So right above the negation key, it says answer. So if I hit second negation, it'll tell me the answer from the previous line. Some other calculators might have an ANS button over off to the side somewhere, so you can check your calculator to see if it has that feature. On this one, I'm going to do 10 divided by, and then I'll press second negative, and you can see it tells me ANS. So that means it's going to take the previous answer, and we'll divide 10 by that. And we get 15. That was unexpected. All right, let's try on the right-hand side here. So now we have 10 divided by 2. I know that's 5. And now we got to divide that by 3. It's not 15. So it looks like since we changed the order, or we changed the grouping rather, for division, we did not get the same thing. So it looks like dividing is not associative. Okay, how about exponents? So here, if I follow my order of operations, I'm going to do things that are up in the exponent land first. Remember, there's implied grouping here. So 2 to the third power is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So this is 10 to the 8th. That should be a 1 with 8 zeros, but let's check. 10 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 1 with 8 zeros. So it looks like 100 million. Okay, now let's take a look at 10 squared to the third. So 10 to the second power is 100. And now let's raise that to the third power. 100 raised to the third power. Oh, I can see on my calculator it's shorter. 1, 2, 3, 4, 5, 6. So that's only going to be 1 million. So it looks like if I change the order of the grouping, here the 2 to the third was grouped together, whereas here the 2 squared was grouped, that's going to change the answer. So exponents look like they do not have the associative property. All right, let's take a look here. So here we have some radicals. So I've grouped the index of 2 and the radicand of 10 together. So we're going to figure that out first. And then we'll figure out the cubed root of that answer. On the right-hand side, now the cube and the 2, so the cubed root and this 2 are linked together. And then we have the square root. So let's see if we we have whatever this is, root. So let's see if we change the grouping of numbers with radicals if we get a different answer. And this one, I'm just going to type the whole thing in my calculator because I think this is going to get pretty hairy. So I have the third root of, in parentheses, oops, I want the second root of 10, close those parentheses. So what I've got here looks pretty close to what I've got here. Okay, it's about 1.4678. Okay, let's see if that's what we get here. So I'm going to put in parentheses, and now I need the third root of 2. Let's close those parentheses. So that's this piece here. And now that is the index of the radical. Ooh, 6.2187. So we now have a different answer. So it looks like radicals don't have the associative property either. So as with commutative property, when I look at the associative properties, the ones that look like they're associative are adding. I can change the grouping for adding, and multiplying. I can change the grouping when I multiply. Okay, so this brings us to theorem 2 that says addition and multiplication are associative operations. Subtraction, division, exponents, and radicals are not associative operations. So we're going to figure out whether each of these equations demonstrates the associative property or not. What we are looking for the associative property is that the numbers are in the same order, the grouping has changed, and we get the same thing on either side. So in example A here, we have the same numbers in the same order on either side, 5, 4, 1, 5, 4, 1. The operations subtract and add are the same, and what has changed is here the 4 and the 1 are grouped, and here the 5 and the 4 are grouped. This one does not demonstrate the associative property, and that's because of this subtraction. If I follow my order of operations, I'm going to end up getting something different. 4 plus 1 is 5, and 5 minus 5 is 0. While here, 5 minus 4 is 1, and 1 plus 1 is 2. So we get different things on either side. This is because subtraction is not an associative operation. So if you subtract, you're going to get different answers. Let's take a look at part B. So part B has 6 times 3 plus 2, and 6 times 3, and then plus 2. I have an inkling that this one is not going to be right, and my inkling is because here the addition is grouped, while here the multiplication is grouped. And we didn't see any of that on the previous page. We just had all adding or all multiplying. So we still have the same numbers in the same order, and the grouping has changed. So let's see if that made an impact on the answer. 3 plus 2 is 5. And if I multiply 5 by 6, I get 30. Here on the right, 6 times 3 is 18. And if I add 2, I only get 20. So this is not showing the associative property because we got different answers on either side. Now, part C is looking much more like what we had on the previous page. We've got all multiplication, all the same numbers, 4, 3, 2, 4, 3, 2, and the grouping has changed. We've got 3 times 2 on the left and 4 times 3 on the right. So my inkling, my guess is that this yes is going to show the associative property. But let's check. Let's make sure we get the same thing on either side. So 3 times 2 is 6, and 6 times 4 is 24. 4 times 3 is 12, and 12 times 2 is 24. So yeah, we got the same thing on either side, and the only thing that changed was the grouping. So this is commutative. All right, for this last one, let's see what happens. We've got 2, 7, 11, 11, 7, 2. And here the 7 and 11 are grouped, and here the 11 and 7 are grouped. So it looks like on this one, the grouping hasn't changed. The 11 and the 7 were grouped on either side. So since the groups didn't change, this is not showing associative. Do you remember what we call it when the order changes? This is demonstrating the commutative property. So the groups have remained the same, so it's not associative, but the order of the numbers within the group, as well as the addition on the outside, has changed. So for some extra practice, take a moment and determine whether or not each of these equations demonstrates the associative property or not. In the next video, we're again going to return to those weird operations just to get some extra practice in an uncomfortable space with associativity. Looking forward to seeing you then, and in the meantime, have a great day.